On July 22, 1888, in the rural town of Preluka, then part of the Russian Empire, now Ukraine, Selman Abraham Waksman was born. Little did anyone know that this young boy would grow to become a towering figure in microbiology, profoundly impacting human health and ultimately ushering in the age of antibiotics. Waksman's pioneering research, particularly his relentless exploration of soil microorganisms, led to discoveries that revolutionized the treatment of infectious diseases and earned him the Nobel Prize in Physiology or Medicine in 1952. Waksman's early life was marked by intellectual curiosity and a drive for education. Faced with limited opportunities in his homeland, he emigrated to the United States in 1910. He enrolled at Rutgers College, now Rutgers University, in New Jersey, where he pursued a Bachelor of Science degree in agriculture, graduating in 1915. He continued his studies at Rutgers, earning his master's, and then obtained his Ph.D. in biochemistry from the University of California, Berkeley, in 1918. His academic journey brought him back to Rutgers, where he spent the bulk of his distinguished career. Waksman's primary focus was soil microbiology, a field that, at the time, was not widely recognized for its potential in medicine. He was fascinated by the intricate ecosystem beneath our feet, particularly the diverse array of microorganisms that inhabit the soil. He meticulously studied their interactions, their roles in decomposition, and their unique metabolic products. This painstaking research laid the groundwork for his groundbreaking discoveries. One of Waksman's most significant contributions was his systematic approach to screening soil microorganisms for antimicrobial properties. He recognized that certain microbes produce substances that could inhibit the growth of others, a phenomenon known as antibiosis. Building on the earlier observations of scientists like Louis Pasteur, Waksman set out to harness this natural phenomenon for therapeutic purposes. It was Waksman himself who, in 1941, coined the term antibiotic to describe these microbial substances that could kill or inhibit the growth of other microorganisms. His laboratory at Rutgers became a hub of intense research, with Waksman and his students diligently examining thousands of soil samples. Their efforts bore fruit with the isolation of several antibiotics. However, it was the discovery of streptomycin in 1943 that marked a monumental breakthrough. Isolated from the soil bacterium Streptomyces griseus, streptomycin proved to be remarkably effective against a wide range of bacteria, including Mycobacterium tuberculosis, the causative agent of tuberculosis, TB. Prior to streptomycin, TB was a devastating and often fatal disease with limited treatment options. Waksman's discovery provided the first truly effective treatment, dramatically changing the prognosis for millions of patients worldwide. Streptomycin's impact extended beyond TB. It also proved useful against other severe infections like cholera and typhoid fever. This discovery firmly established the concept of antibiotics as a powerful tool in medicine and ignited a global search for new antimicrobial compounds. Waksman's dedication to science extended beyond the laboratory. He was instrumental in establishing the Institute of Microbiology at Rutgers University in 1949, serving as its first director. This institute became a leading center for antibiotic research and development, fostering future generations of microbiologists and continuing the legacy of discovery. The royalties from his patents, particularly for streptomycin, were generously used to fund the institute, demonstrating his commitment to advancing scientific knowledge for the benefit of humanity. Despite some controversy regarding the precise credit for streptomycin's discovery, particularly with his graduate student Albert Schatz, Waksman was solely awarded the 1952 Nobel Prize for his ingenious, systematic, and successful studies of the soil microbes that led to the discovery of streptomycin. The Nobel Committee recognized his overarching leadership and the systematic framework he established for antibiotic discovery. Selman Waksman's legacy is immense. His meticulous research into soil microbiology, his systematic screening methods, and his pivotal role in the discovery of streptomycin not only provided a cure for tuberculosis, but also opened the floodgates for the entire antibiotic era. His work fundamentally transformed medicine, saving countless lives and forever changing our approach to infectious diseases. He passed away on August 16, 1973, leaving behind a scientific heritage that continues to inspire and impact the world.